Welcome back, ladies and gentlemen, to Physical Science with Mr. Kenton. Glad you could join me today. We're going to continue our discussion of the atom, and we're going to get a little bit more specific by looking at the two main models of the atom that we need to be familiar with. Okay, and if you think about a model, just even before we get into this, models are representations that help us visualize something and to be able to explain it in a way that can help us better grasp what it is that we're looking at. And so we're going to be looking at two of those models, and the first one is the Bohr model of the atom. Okay, so it's named after Niels Bohr. He is a Danish chemist, physicist, and he is the person who came up with what is known as the planetary or orbit model of the atom. Okay, and when you think about that, when we say planetary or orbit model, think about how the solar system that we live in is arranged. You've got the sun that's at the center, and then you've got the planets that all orbit around the sun at fixed distances, and they follow a specific path. And so in the Bohr model of the atom, it's going to follow something very similar. So, the sun is the center of our solar system. So for an atom, the nucleus is the center of the atom. That's what's in the center. And then you've got the electrons that are in those specific orbits that are at specific distances around the nucleus. Now, slight difference here when we're talking about the electrons and their orbits and these distances. I want you to think of it as you've got increasingly larger and larger spheres that are stacking on top of one another, okay? So think of it, it's like closest to the nucleus, maybe the size of a golf ball. But then covering that golf ball would be a tennis ball. And then covering that tennis ball would be, a basketball. And just keep thinking the ball keeps getting bigger and bigger. That's what these specific orbits and distances look like. The electrons specifically are able to move on their specific path, but they're also able to move further or closer to the nucleus of the atom. So electrons can move farther away from the nucleus, or they can move closer to the nucleus. Specifically, they're within the Bohr model, they're what are called valence electrons. And so the valence electrons are the electrons that have the highest energy and are the furthest away from the nucleus for that particular atom, right? So, and these electrons are the ones that are most responsible for chemical reactions and bonding for our specific elements on the periodic table. Now, I will mention, because we talked about how models are representations of something, the Bohr model, unfortunately, does not accurately describe all of the atoms on the periodic table. In fact, it only describes one of them accurately. And so, of course, this is something that we used for a long time, but chemists were looking for a way to better describe what atoms actually look like. Okay, so that's why we have the second model that we're going to be looking at shortly. On this next slide, what you're going to see is this is an example of the Bohr model. Now, we talked about previously that the atom is made up of three different particles. You've got protons, neutrons, and electrons. All right, and if you remember, we said protons were positively charged, we said neutrons were neutral, and electrons were negatively charged. And so if you're looking at this image, in the middle, you've got those red spheres, which are protons. You've got the green spheres, which are neutrons. Those make up your nucleus. And then as you can see, there are two rings that are moving around this particular nucleus. So this is why they call this the planetary model. You've got your nucleus at the center, and you've got those two rings in this particular case for this atom where electrons can reside. And then the blue spheres, as you can see, those represent the electrons that this particular atom has. Now this is the Bohr model of the atom, and this is specifically for nitrogen. Okay. Now we move into our second model, and the reason why we needed a second model is because the Bohr model didn't accurately and adequately describe all of the elements on the periodic table. Now, from the Bohr model and even in the electron cloud model, some things do remain the same that it's important to recognize. That all atoms have two parts, right? There's a location where the protons and neutrons are going to be found, and then there's a location where the electrons are going to be found. So anytime you're looking at an atom, it's always going to have those two locations, right? And so in the electron cloud model, you've got the nucleus, so we're still using that same idea here. And this is the central part of the atom. It's at the very center of the atom. Now, the nucleus, this is where the protons and the neutrons are located within your atom. They're in the nucleus. Now, if you're remembering, because protons are positively charged and neutrons are electrically neutral, that means that the nucleus itself has an overall positive charge. Okay, it's positively charged. Now, when we're talking about the mass of the atom, because we talked about how all matter has mass and occupies space, in terms of the mass of the atom, almost all of it is confined to the nucleus. The protons and the neutrons contribute to the mass of the atom. Now, when you think about that space component, the volume component of the atom, the nucleus is actually very small in comparison to the actual size of the atom itself. So it's much smaller. Now, the electron cloud, like it sounds like, is a cloud where the electrons are found. Okay. So the remaining space the atom occupies that surrounds the nucleus, that is the electron cloud. So the electrons are located here. Of course, because the electrons are there, that means that the electron cloud is negatively charged. And the electron cloud accounts for the majority of the volume that the atom actually occupies. So the nucleus takes care of our mass component. The electron cloud deals with the majority of our volume component, or our space component. Now, here is an image, a representation of what the electron cloud model represents. Now, I want you to notice how this is different from the Bohr model. Remember, the Bohr model, we had very specific distances that electrons were traveling. They were in very specific travel patterns. They had these orbits. In the electron cloud model, that's not the case. There are no specific orbits for electrons, but it does have a lot of those same components. You still have a nucleus that's in the center with your protons and your neutrons, and then you've got electrons that are surrounding that nucleus in the electron cloud. Okay, and as this diagram mentions, it says that the electron cloud is a probability model. It gives you probable locations where you can find an electron. And one of those probability representations is actually shown here, and it just looks like a circle, right? You've got the nucleus in the center, that's that red location, and then those blue dots represent possible locations of an electron. Obviously, the places where it's much darker blue, higher probability of actually finding an electron. Okay. Now, to sum up protons, neutrons, and electrons within our model, I think this is important. We need to understand these subatomic particles. So we understand that an atom is made up of electrons, protons, and neutrons. So there are different ways that chemists and scientists represent these things, and I want you to be familiar with that. So you can see here an electron, it gets represented with a lowercase e with a negative as a superscript. Now in that symbol, that's just letting you know that the electron is negatively charged. In terms of the charge, we see that the charge of an electron is -1. For its mass, it's 0 AMU. Now, AMU is a special unit that's used to measure the mass of subatomic particles in atoms, okay? Because you can't measure the masses of atoms like you can, say, an orange. You can't just go put an atom on a scale and get a readout. So scientists came up with a special unit to use, and that's AMU. That's the unit that's used to measure the masses of particles like that. So you can see the electron has a mass of 0 AMU, and we've got its location, which is in the electron cloud. You've got our protons. Its symbol, a lowercase p, with a positive superscript directly to the right of it, indicating that it has a +1 charge. As we can see, it's got that +1 charge, and it has a mass of 1 AMU. So for every 1 proton you have, that's going to contribute to the mass of the atom by 1. So 1 atomic mass unit. And that proton found inside the nucleus. And last but certainly not least, you've got the neutrons. So neutron symbol is an N, no superscript, no charges there, letting us know that it's neutrally charged. Charge has a value of 0 here. Its mass is 1 AMU as well. So for every neutron you have, you're going to increase the mass of your atom by 1. And it's found inside the nucleus. I hope this was helpful for you guys.